In this video for section 14.2, we're going to talk about how to write an equation for the linear relationship between two quantitative variables. If our equation contains only one independent variable, this is called simple linear regression. Sometimes it's called finding the line of best fit. If there are multiple independent variables, then it's slightly more complicated, and we're going to look at that later. So remember from algebra that when we write the equation of a line, we use y equals mx plus b form. M is the slope and b is the y-intercept. MyLab and Minitab are going to write this slightly differently because they like to write the constant term first. And in the book, you will see they're going to use b0 to represent the y-intercept and b1 to represent the slope. So just keep in mind that the b0, the number that comes first here, that's not in front of x, is the y-intercept. The number that is in front of x is the slope. We also want to remember from algebra what the slope and y-intercept tell us about the line. So the slope measures the average change in y for each 1 unit increase in x. So if we have a slope of 12, that means that as we move 1 to the right, or we increase x by 1, then the line is going to go up 12, or there's going to be a 12-unit increase in the y-coordinate. If the slope is negative, then that means that as we move 1 to the right, or increase x by 1, the y value is going to decrease by 12 because it's going to go down. The y-intercept of the line tells us the y value when x is 0. Depending on the context, this may or may not be meaningful when we're talking about linear regression. And it really depends on partly on whether 0 is close to the rest of the data values or not really close to, or if it just makes sense to have 0 as an x value. Sometimes it does and sometimes it doesn't. So if we look at a data set, we can picture drawing a line through the data points. This picture is from the book, and there are different ways that we could draw that line. But when we have the line of best fit, it's the line where the total distance between the points and the line is minimized. So Minitab is going to do the work of figuring out what that line is for us, and they're going to give us the equation. But just to keep in mind that the line of best fit, we're taking each point, measuring the distance to the line, and then we want that number to be as small as possible. So when we talked about correlation, we used a formal hypothesis test to determine whether the correlation coefficient was significant. And we can also use this kind of test to determine whether the slope is significant. So the null and alternative hypotheses will look like this. Our null hypothesis is that beta 1 equals 0. So remember, we are using b1 for the slope, so the beta here is the Greek letter version of that. Our alternative hypothesis is that beta 1 is not equal to 0. So I'll just put a little note in here to remind myself that beta 1 is slope. So as usual, we're going to use Minitab to calculate the p-value. We want to compare the p-value to alpha, and we will reject the null hypothesis if p is less than alpha, or the significance level given to us in the problem. So we're going to look at our same example that we just looked at in section 14.1, the Midwest Distribution Company. And so as you remember, the company wanted to know if there was a relationship between sales and the number of years that the employee had been with the company. So what we're going to do now is find the regression equation and interpret the regression coefficients, and then also test the slope coefficient for significance. So we have our same Minitab worksheet here. What we're going to do is we're going to go to Stat, go down to Regression, and then you see the second choice here is also regression. And then it's not quite showing up on my screen, but to the very right side, you see where it says Fit, it says Fit Regression Model. So I'm going to click on that. And then I'm going to put in the responses box, I'm going to put the what I want on the y-axis. In the continuous predictors box, I'm going to put what I want on the x-axis. So as you might remember, I think that the number of years is going to be the predictor, So I'm going to put that on the x-axis, or that is my independent variable. I think sales might depend on how long someone has been with the company. So sales is going to go into the responses box. Then I'm going to click OK. And here are my results. So it puts the regression equation at the top. One thing about this, if you click on the regression equation, you may need more digits after the decimal point when you're doing the homework, as usual. You cannot change the number of decimal places in the regression equation box. What you can do is if you go down here to the coefficients box, these coefficients in this column that says COEF, these are the coefficients in the regression equation. So you see that 175.8 and the 49.9. Here, I can click on this column, and I can change the number of decimal places here. So if I want 4 digits after the decimal point, I can select that. However many digits I want, I can change that there. So these are the coefficients. This is my equation. When it says 49.9 years with Midwest, this is going to be my x. Years with Midwest is what I wanted on the x-axis. So it's y equals 175.8 plus 49.9x. So that's my equation. The other things that I have in my chart, if I want to look at what I was looking for here, I'll write this down. So my equation was y equals 175.8 plus 49.9x, or however I want to round those numbers. The other things that I was looking at was interpreting the regression coefficients. So that's looking at these numbers and then figuring out what they mean. So the slope is 49.9. And so what the slope means is that for every 1 unit increase in x, and x in this case is the number of years in the company. So this means that for each additional year worked, sales increased, because my slope is positive, by $49.90 on average. So that doesn't mean that every single person increased exactly $49.90, but on average they increased $49.90. The Y-intercept, or the intercept, sometimes they leave the Y off, the intercept is 175.8. or $175.80. And that is the Y value, or the amount earned, when X is 0. So this would be the amount earned by someone who had just started working there. And in this case, that might make sense. Because if you had 0 years of having worked with the company, then you maybe started within the last year, and you could still have $175 worth of sales maybe when you first start working there. So that would make sense. So the next thing that we want to do is test the regression slope coefficient for significance. So I'm going to go back to my Minitab output, and if I look here, the numbers that I'm looking for are the years with Midwest. This coefficient here, this is the slope, right? This 49.9. And so I'm looking in that row. And what you're going to need for the homework is the t-value and the p-value. So I see a t-value of 4.75 and a p-value of 0.001. Remember, if you need more digits, again, you can always get those by using the drop-down arrow. So my t-value, 4.75. And p-value, 0.001. And so comparing my p-value to alpha, p is less than alpha, whatever alpha I'm using. In this case, it's 0.05. So that means we reject the null hypothesis. So, going back up to my hypotheses up here, rejecting the null hypothesis means that I have evidence to support the alternative. So I have evidence that the slope is not equal to 0. And then the last thing that you're going to need in order to answer the homework problems about this is something called the coefficient of determination. So the homework is going to ask you for the coefficient of determination. And that in the table is this RSQ, or that stands for R squared. So that is 69.31%. And what that tells us is it tells us the percent, or the proportion. So I'm going to underline that because you're going to need that word in the homework. It's the proportion of variation in Y, whatever the Y is. So in this case, it would be the proportion of variation in the amount of sales that is due to X. So the proportion of variation in the amount of sales that is due to the variation in the amount of years worked. And so in this case, that is this percentage. For the homework, you're going to want to write that as a decimal. So it would be 0.693. And then lastly, when you're doing the homework for this section, some of the questions are going to ask you about the correlation. So remember, to get the correlation, we're going to go up here to stat, go to basic statistics, and then we're going to go down to correlation here. So you're going to need to do this for the homework as well, because it is going to ask you for the R value and the P value for the correlation coefficient. So since we did this last time, these values should be pretty familiar. I got my correlation of 0.833. And then if I want the p-value, what I need to do when I do this is make sure that I go to results and then check the box that says pairwise correlation table. And that is going to give me my p-value of 0.001.